In the previous video, you learned how the production of plastics can be customized for a diverse range of purposes and products that are useful for our daily lives. But what happens to those plastics after we use and dispose of them? When we think about a product, we need to consider not only its production, but also its waste and impact on the environment. Plastic takes a long time to completely decompose. This means that plastic waste usually remains on Earth for a long time. These waste plastics not only pollute our environment, but also harm living organisms in various ways. In this video, we explore how science and technology enable us to minimize the environmental impact of plastics. You will find out what we can do with plastics after we use them, towards a sustainable future. First, let's have a pop quiz. Biodegradation is a process where microorganisms decompose matter. So how long does a plastic bottle take to biodegrade? Drum roll, please. The answer is 450 years. That's like a 15-year-old person reliving his or her life 30 times. Since plastics have such a long life, it is irresponsible of us to think of burying every plastic object we no longer need, as land is scarce in Singapore. We will need larger landfills over time, and future generations will run out of space very quickly to bury the unwanted plastics. Simply burning plastics into ash has an adverse environmental impact too. Because first, fossil fuels are used for burning, and second, burning plastic releases pollutants like soot that causes air pollution. Hence, managing plastic waste more sustainably through the 3 R's, reduce, reuse, and recycle, is important. Let us learn about some methods that industries use to manage plastic waste.
A lot of plastic packaging becomes waste. So we actually reduce the use of plastic in our packaging design, the first R. For example, instead of using plastic cushion wrap, we developed a protective wrap made of recycled paper. In the efforts to reuse and recycle plastics, the second and the third R, we have turned old water bottles into recycled insulation that is used to make winter parkas and jackets. We also recycle plastic fibers to make heavy-duty scrubbing sponges like these that can be reused not only once, but multiple times. With our new sustainability goal, 3M commits to reduce its use of new plastic made from petroleum by £125 million by 2025. Our Tuas facility is a zero landfill site, which means that 100% of the waste generated is either recycled or converted to energy.
Thanks, Jannik. We've learned about how the industry is implementing the 3 R's. Another way to think about recycling is the recovery of natural resources. The more resources we can recover from waste products, the less we need to extract from the earth. After all, petroleum, which is a key ingredient for the production of plastics, comes from crude oil which is extracted from the earth. So how exactly is plastic recycled? Broadly, plastic can be recycled mechanically or chemically. To understand mechanical recycling, let's look at the typical clear plastic bottle. At a recycling plant, plastics are sorted, cleaned, shredded, and melted into pellets that can be made into either new plastic bottles, woven into fibers for polyester clothing, and much more. Let us now look at how chemical recycling of plastics is used to recover resources. Aleli, an engineer with Environmental Solutions Asia, will explain the process to us.
There are many different types of plastics used in the world. To help with recycling, a lot of consumer plastics are labeled with a recycling triangle and a number from 1 to 7. For example, the plastic beverage bottle is number 1 PET, while the bottle cap is the number 5 PP. As PET and PP are different compounds, their chemical composition is different. This means they react differently when the same separation technique is applied to them. Using a chemical recycling technology, plastic waste with numbers 2, 4, 5, 6, and sometimes 7 can be turned into what we call new oil that can be used as a raw material component in fuel or to make plastics like tires and mattresses. Even though new oil is an innovative way to recycle plastic, there are remaining plastics like plastic number 3 PVC that is used to make water pipes, which are very difficult to recycle. So since this is not possible to recycle plastic waste 100%, the best thing is for all of us to reduce plastic waste actively and continuously.
Now we understand the numbers on our plastic products. The numbers help sorting of plastic waste for recycling, while the triangle symbol informs us on their recyclability. If the recyclable symbol is present, the plastic products can be thrown into the blue recycling bins. The recyclable symbol better informs us on the kind of plastic products to buy to better support sustainability efforts. Beyond the 3 R's, science and technology play an important role in the future of sustainable plastic waste management. Let us find out more from Professor Sierin Lim and Dr. Rupali Reddy of NTU School of Chemistry, Chemical Engineering, and Biotechnology.
Every year, a large amount of plastic is generated. Many researchers around the world, including our lab, are hard at work to find novel solutions to tackle plastic waste problems which affect our air, land, and marine ecosystems. As researchers at the Bioengineered and Applied Nanotechnology and Molecular and Cellular Bioengineering Laboratories at NTU, we use biotechnology to design enzymes and program microbes to convert plastic waste to other useful molecules.
Just like computer codes are used to program computers, we use genetic codes to program microbes. We can instruct some of them to produce enzymes to break down used plastic bottles to their monomers. While we can instruct the others to use the monomers to produce valuable products such as fuels, food additives, or medicines.
The fascinating thing is that we do all these through bioengineering in our laboratory.
What we have described is only the tip of the iceberg of what science and technology can do.
Beyond developing solutions for plastic waste, bioengineering and biotechnology can be used to tackle a wide variety of issues in our sustainability efforts. We are only limited by our imagination. You too can make a difference to the environment.
One material, thousands of applications. Isn't it amazing? In schools and workplaces, we need the diversity of minds and the diversity of ideas from both women and men to enhance creativity. If we put our minds together, we can make better decisions, solve big problems like sustainability challenges that our planet is facing, and together, we can make new discoveries. Imagine the limitless possibilities of what you can do with STEM.